Well, welcome to COJUG, everybody. My name is Chris Judd. We are very fortunate to have Ethan here tonight talking to us about OpenRewrite. I don't think I have any announcements. I would like to thank Manifest Solutions for providing dinner. And this is being recorded, so anything that you say embarrassing will go out to the world because we will be posting it on YouTube. I don't think that there's anything else, so I will turn it over to Ethan.
Awesome. Hello, everyone. My name is Ethan Wirt. Today I'm going to be talking to you guys about OpenRewrite, which is a automated code refactoring open source project, talking about how it works, and then doing a small case study about how we use it at JPMorgan Chase. Of course, right when I get up here. Maybe it's not on the screen. All right. A little bit about me. So like I said, my name is Ethan. I'm a recent graduate of Ohio State here in Columbus. I have a bachelor's in computer science and a business minor. Right now, I work as a software engineer at JPMorgan Chase, also here in Columbus. Make sure everyone can get in, admitting people as we go. Yeah, so I've worked at Chase for almost 2 years now. I worked here as an intern before my senior year, and then throughout my senior year, I worked part-time, and now I'm a full-time employee. So loving it, and yeah, get to learn a lot of cool things, one of which is what I'm about to talk to you today about. All right, so I do have a disclaimer that I am required to say. But it's important that no opinions are representative of JPMorgan Chase. They are of my own. JPMorgan Chase does not endorse OpenRewrite or any technology to talk about today. And also, just like firm-specific information is not really the focus of this talk. It's not going to be discussed. More of just the high-level how we use this technology, and really just like kind of a discussion about what OpenRewrite is and the power that it has. So. I'm just going to get that out there, and then, yeah, the agenda. We're going to start off with like an introduction to what OpenRewrite is, what the purpose of it is, what it's useful for, and just kind of a high-level overview. Talk about how it works at a more lower level, still fairly high level, but more of the architecture, design patterns is based on, in preparation for the demo, which is going to follow that. I'm going to go through an example of a dummy application and how OpenRewrite can do various transformations to it. And then also going to show how you're able to create custom recipes along with the built-ins that OpenRewrite comes with, how those work. Some really cool stuff there. Talk about other use cases, both for yourself, maybe in your personal life, your work life, etc. Other use cases for it, and then we're going to do that case study and kind of talk about it at a very high level, what like a framework migration might look like at a company at the scale of JPMorgan Chase. It's very interesting to see how OpenRewrite is capable of optimizing things in ways that, you know, I like to say like the limit is the imagination, because you know the possibilities are endless with this, and you're going to find that out pretty soon with especially with the demo. So. I'm excited to share that with you. Close off with some challenges and considerations, and then if anyone has any questions, we'll get into them then. Awesome. All right, so what's the problem here? First of all, has anyone heard of OpenRewrite, used OpenRewrite, other than people that I know? Okay, that makes it more fun, I guess. So the problem here is, how do we take a code base and refactor it in a particular way? So that could be, I'm going to list a few examples here. If my clicker will still work. You know, dependency upgrades. Everyone has dependencies in their projects. When that dependency upgrades, what if there's a security concern? Or, you know, maybe it's not as simple as just changing something in your configuration file. Maybe there's extra edits that need to be done to your files and many other files. Then you have that long documentation where it's like, oh, this is estimated to take an hour to upgrade, but really it takes so much longer than that, and you run into more problems. So, I mean, that right there, very common use case. Also, enforcing styles is a common thing. You know, maybe from the get-go, if you have an IDE that supports some sort of style enforcement, then you have that. But maybe you've been coding on a project for a while and you want to take the whole thing and then enforce some sort of style on it. It's a great use case for that as well. And then many others. I mean, like I said, there's countless different ways that this can be used. So kind of what I'm alluding to here is that manually updating code is very slow. It's prone to human error, and for the larger the code base is, the more daunting that task may be. And the more dependencies you have, it could get even worse as well. So I say enter OpenRewrite. The solution here that I'm going to be talking about today, OpenRewrite, I said it's a open source automated refactoring ecosystem. It's developed by Modern. They have a few other code quality products that they offer, but OpenRewrite is definitely at the top of the list. So using OpenRewrite, developers are able to take any code base that they have and use things called recipes, which are prepackaged bits of code that accomplish some sort of transformation task. Give the example here of eliminating tech debt, really good individuals and companies alike. But generally, the idea here is that we're reducing the time and effort that is spent manually refactoring things. The main point here is that one person can create this recipe. Either it's one of the out-of-the-box ones that OpenRewrite provides, or you write your own custom recipes. One person has to do that, and then X amount of people can use that. And that's really powerful for yourself and for larger groups of people at scale, which is something that I think the case study does a really good job of showing. So no reinventing the wheel. That's really good. All right. So I mentioned it's an auto refactoring engine. It runs these prepackaged recipes for these things. I kind of touches on the points I made before. But the main idea here is that it takes things that might take hours and days and takes it down to seconds to minutes. OpenRewrite has a large language and framework support. It was initially made for Java support, but now it supports a lot of different languages, a lot of different frameworks. I have some stuff on the next slide to show those off. The main way that you use the recipes are through build tools for Maven and Gradle. Today during the demo, I'll be using the Maven rewrite plugin, and but you can use either one, whatever is more convenient for you. So, highlighted a few. This is like straight off their website. It's a little small maybe for people in the back, but straight off their website, each one of these little tabs, if you click into them, there's a list of recipes that are available for each of these languages, frameworks, etc. I mentioned that it's almost, or it was originally made for Java support, but it supports many languages and frameworks now. Highlighted a few that might be relevant to the average developer. So just, that was a high level overview. I'm going to go into now for a little bit, like kind of how OpenRewrite works at a lower level. Some really interesting stuff going on here. A lot of tree traversal stuff, a lot of fun design patterns, and I think it's really interesting. So not only is it interesting to learn about how it works, because it's a really cool tool, but also if you do plan to use OpenRewrite and do some more advanced operations with that, having this knowledge of how it works at a lower level helps you author those recipes. So here is that when you use OpenRewrite on your source code, all of the code is converted into a lossless semantic tree, or LST. So this picture here kind of shows, I'm sure many of you have heard of the abstract syntax tree. They're lossless semantic trees, basically an abstract syntax tree, but with a ton of metadata. And that metadata is used to serialize and deserialize it, so that you're basically giving this program, your entire code base. It does some sort of transformation on it in this tree structure, and then spits it back out almost exactly as it was before, given your modifications. Right? There's a lot of extra data that needs to go in there. And OpenRewrite does a great job of optimizing that mess that is that tree right there. So the idea is that the tree is traversed, and then edits are made at the node level. And the node level meaning like each individual component that I'll start like to break down here, and how they're categorized. Okay, so here's an example of how Java is categorized by OpenRewrite. So I'm sure like many of you know how grammars are broken down. This is how their grammar kind of works and how each individual component of a Java file would be broken down. So the very top here is the compilation unit. This is the one I'm going to focus on today. It is like the highest level that Java has in this tree structure. And basically, if you like get to a compilation unit, you have access to everything in that source file, and you can do whatever transformations you need on that source file. The idea with OpenRewrite is using the design pattern that I'm going to talk about next. You would traverse this tree in a way that, let's say I need to modify a single piece of text, then I would just go to that piece of text and change, transform it, manipulate it in any way that you need to. But maybe I need to see the entire source file. So you go up here and you can see how it breaks down into their smaller structures. That's how it's stored at a super high level within the tree. So like I said, we're going to focus on the compilation unit first. Well, not first, primarily, just to kind of abstract all that stuff away. So the idea here is that the design pattern that we follow is the visitor design pattern. Really cool how this works. If you've heard of the visitor design pattern before, you might have an idea of how this kind of operates. But I think it's really cool how for specific languages, this design pattern kind of guides OpenRewrite in the most efficient way possible to get to where it needs to be. So we have these language-specific visitors at the very top. So this is a Java visitor. We're working with a Java compilation unit, so we're going to work with a Java visitor. This Java visitor will extend, your base tree visitor class. So any language has its own visitor in OpenRewrite. So, there's a Java visitor, there might be a YAML visitor, Python visitor, et cetera, et cetera. It gets this bolded visit method, which is a generic visit method. And as it traverses the tree, it just continues to call this visit method. And anytime that it reaches a specific type of tree, say a compilation unit, it will then dispatch to the correct language-specific method based on the tree, right? So that was a lot. I'll break it down a little more. So at a high level, we have our language-specific visitor, which in this case is the Java visitor, right? It's going to traverse through the source of the LST. Then going to use double dispatch, which is a trait of the visitor design pattern, and it's going to follow the course of extends and implements all the way down, and it'll call the compilation unit when it sees it, which is really cool. As a compilation unit. This can be extended to any other language, any piece. We could be working with the identifier, which is the name, and then we'd have a visit identifier method, so visit X. So the idea here is that you, as a OpenRewrite authorer, you're making your own recipes, or if you're looking into the built-in recipes, you can override this visit compilation unit, visit X method, and then make changes to the code there. So if I visit the compilation unit, then I have access to everything right there. And then instead of just continuing to traverse the tree, which is what it does by default, we would make some changes. Anything we want. And I'm going to kind of show that. It's kind of a lot. So the recipe uses this visitor to make changes. So once we zoom out one more level of abstraction, first, here's an example of what something might look like. This is an example of some code off of OpenRewrite's documentation site of, one of the recipes. And you see it's overriding this visit compilation unit method. And instead of just continuing to traverse the tree, it's making some modifications on the text. And in this case, it looks like it's taking some of the characters, either appending or removing white space based on some conditions, and then continuing to traverse the tree. So you can do anything you want in here, and it's pretty powerful. So zoom out one more time to recipes. So we had the individual tree nodes, right? Depending on what you're working with, whether it's the compilation unit or it's like a single line of code in the name of a variable or something. Then we zoom out to the visitor level. We have the Java visitor, which dispatches to the correct type of tree that we're working with. And then we have the recipe level. So the recipe uses a visitor, whether a custom one or one that OpenRewrite has, to make changes to the source code according to your specifications. So OpenRewrite provides an extensible recipe class that you have to implement the visitor for. So you have your custom recipe. In this case, if I had that visitor that we just saw on the side there, this custom recipe would be used for removing white space from strings or something, right? That's its job. You invoke the recipe, and it does that on the source code that you provide. Just a little bit more about recipes, and then we'll get into kind of showing how it works. So, types of recipes. One is just like your standard built-in recipe that has the get visitor method. So all you have to do is one visitor, one time you make changes. You can make changes to multiple things. You could have that visit compilation unit. You could also have a visit identifier, and you're doing multiple things in that visitor. You're just one time that you make changes. OpenRewrite provides scanning recipes, which has a second visitor, which essentially, as the name would suggest, it scans the code one time, populates some data about it. Maybe you're like checking, oh, is there anything in my source code, or are there any files that start with this word or something? And if there are, the visitor will do these things to it. Maybe you need some key information to get it done. So scanning recipes are good for that. Not really important for what we're talking about today, but a good thing to know for the full picture. In the demo, I'll just be working with a regular recipe, showing how that works. Recipe execution, you can either do it declaratively or imperatively. Declaratively is essentially you pre-configure a YAML file, and you say, these are the recipes I want to run, package them up, send them out, and then run. Simple as that. Imperatively is maybe it's in one of those files, but in that recipe, if something happens, you might call a second recipe. Things can chain, other cycles can be produced. You can declare them in actual Java files as you go. So it's worth noting that like in the OpenRewrite development environment, you're also working with Java. So you're programming these recipes in Java, you can call the recipes in Java. Either way, all the recipes are activated through the plugin that you're using. And then I also note that it is possible to create your own wrappers and your own runners for these recipes, which is really useful for maybe not as an individual, it's very useful, but for maybe a larger company. You could create a runner so that every user that uses something that uses your group of recipes that you prepackage and send out can just run it without even plugging information into their source code. Yeah, that's about it for recipes. That's kind of like the high level of everything, and it's a lot. It definitely is, but I think like this demo will help kind of maybe clear a few things up if you are confused. Maybe you got it and you're much smarter than I am, but okay, so this demo is going to be just kind of a dummy application. It is something that is on the OpenRewrite docs page. It's something that is a good repo to use to play around with different recipes. Going to be using the Maven plugin, like I mentioned, and going to try running a built-in recipe, try running a custom recipe, and also kind of writing some of it to see how it works, and then see what changes were made. So, first, let's show off this. This is the documentation that is on OpenRewrite's. This is their official documentation. So this is what I'm going to be using. It's just a sample project. And the cool thing about their site is, here's a quick start for getting the project up and running for this sample project. If you were doing this with your own code, you would just follow steps 2 through 6, it looks like, to get it set up on your own code instead of getting the sample project up and running. So your use case, and like I said, I'm going to be working with this one. Comes pre-configured with everything you need. And yeah, so that's pretty good. Let me know if anything is too small. And I can.
Yes.
Yep.
All right, perfect.
Please big.
I better tell me now than yeah.
One more time.
One more time. Perfect. Okay. So, I'm using VS Code right now. By default, OpenRewrite has a lot of good integration with IntelliJ primarily. But I'm using VS Code right now on my personal machine, so just still can see all the things we need to see. But if you are going to use it yourself and you do have access to IntelliJ, I would definitely recommend that. this is a sample project we have. It's just got a whole bunch of Java files, maybe a few extra things, basic Spring Boot project. So basically everything that you need to configure is within this Maven plugin right here. And like I said, I'm using Maven. I'm not using Gradle, but if you are using Gradle, there's plenty of documentation to follow kind of what I'm doing here with this. But this is where everything happens in this Maven plugin. So the things that are commented out, kind of foreshadowing of what I'll get into. But for right now, I'm just going to talk about activating and running one recipe. So like I said, we're just working with a basic Java file here. And once we put this Maven plugin in, we have access to all the rewrite stuff that it comes with. And one of those is the discover tool. So you can use it if you have Maven integration, but I'm just going to do rewrite discover. So when we run the discover command, we're going to see a list of all available recipes to us, and all of those are going to be the built-in recipes for OpenRewrite. And there's a good chunk of them. And if you want to learn any more about each one of these, you can find them here. This is the best way to find them. Best way to find them would be to go to the documentation site and look up what you need and see if it's available. Those are all the recipes. You can select a recipe and you can select a style if you want to enforce a style. By default, OpenRewrite uses the IntelliJ style. It's just what they do. So anytime that there's no style selected, it's going to do it according to the IntelliJ one. And as you can see, we have one active recipe, and that is the order imports. And that is what I specified right here. So the only active recipe is going to be this OpenRewrite built-in order imports. So order imports, according to the documentation, just groups and orders the import statements. It's going to use that IntelliJ style, which I believe is just alphabetical or something. Doesn't really matter what it's doing, but we can see what it does. If we just we have it active, make sure it's active, and then we can do a Maven rewrite run. You can do a bunch of stuff. Also throws a fun error because something's not configured correctly. Doesn't stop the process. So as you can see, we have our active recipes. It reiterates no active styles. It's going to go with the IntelliJ one. Throw that fun error. But normally, you'll see parsing source files. And then just for a split second there, you saw a running recipe. So this is a really quick recipe to run, small repo. You could hit a git diff, or you can I'll just look at the changes over here. Click on any one of these. It's just going to reorder the imports for every Java file that exists. In this case, this might be something that you want to do, and then you just put it in like this, and there you go. Your imports are reordered. So that's a good example of one use case, and that is a built-in OpenRewrite recipe. So I'm just going to get rid of those changes for now. And the second thing I'm going to do is show a second recipe. I told you that there's two ways to run these recipes. Ignore my MacBook taking off into space right now. But there's two ways to run recipes. There's one that is a declarative way, and I'm going to show that right now, and that's through a YAML file. So I have a second project here that we're just going to package up and bring in as a dependency to the other project. And declaratively here, I have said that I want to run this change package recipe, which is another built-in OpenRewrite recipe. And the parameters for it, you just list here in this format. So you have a list of recipes. You can chain recipes if you want. I could take that order import and then call it here. That one doesn't have any parameters, so you would just call it as is. But this one, we say that we want to find all packages that have vet and move them to the new package veterinary. So I have this in this separate project right here. I'm just going to go ahead and save this to my local machine here using Maven clean install. Package it up. And then just like we did with the other one, go back here, and I'm going to get rid of the order imports, and then I'm going to call this one instead. So an important thing to note here is we're going to bring in that secondary project as a dependency. This just to kind of separate the concerns, right? So we're going to have the separate project responsible for having our recipes, packaging them up, and then bringing them over to this project to use. We bring this example recipes over, and just for clarity, right? So this is the example recipes, same information over here. Bring it in as a dependency, and then any recipe that we define over there, either like I just did in the YAML file, or through Java recipes, which I'll show as well, automatically knows what to do with it. So or.example.recipes vet to veterinary, what I defined in the YAML file right here as the name. It scans through, it knows where all the recipes are, it knows what it can run, and it's only going to run the recipes that you activate. So I've activated this one. Let's see if it works. Save this, make sure Maven has reloaded. Good. And just to be safe, let's check what recipes are active with a rewrite. Discover again. And if there's a problem with it, it will also throw an error. I hope it doesn't, but it will throw an error if there is a problem. And it won't tell you what recipes are active. But in this case, active recipes vet to veterinary now. And that means it not only does it see that it was in the POM file, but like I said, there's no problems with it, the packaged version. So clear the other changes that were over here, and now we're going to do another Maven rewrite run. And this time it will do this change instead of the other one. So two different examples of some of the built-in recipes. You can see that that's the one that's active. Validate them. Yep. Throw the obligatory error. Cool. So I didn't mention this the first time, but basically what will happen is just going to say running recipes, and then it's going to throw these statements here, and they'll say exactly what files were changed, and changed by what as well. So if I had a ton of recipes running and I didn't know what recipe changed which file and why, or if I saw a change that I wasn't expecting, I could go back through this these logs and say, okay, well, this file was changed by this recipe, so I know that that's where I need to look for that change. That's nice to have. But we can see that it's actually better to look at it over here, I guess. Every package file that was in vet is now in a veterinary one. So, like I said, this is just like scratching the surface for some of the recipes that are available, the very complex ones with framework migration, stuff like that. It's some really cool stuff. So, okay, so I showed a built-in recipe, and I showed how to do a different built-in recipe through this YAML file. So now I'm going to show a very quick and very basic example of writing custom recipes. So, like I mentioned before, and again, if I need to zoom, I will just zoom in again. I'll just keep it all. I mentioned before that when we were working with the recipes, we have this. I'm just going to go back to it as well, just so we're all on the same page. This one right here. So the recipe that you write, a custom recipe, will extend this recipe class, and it has to implement this visitor method. And inside the visitor method is where we do any work that we want to do, any changes to the code that we want to make. By default, we also have to implement these get description and get display name. Not really important it's not very relevant to what we're doing right now. But what the one that we're interested in is that visitor method. So there's a ton of stuff that you can do, like a ton of different stuff that you can do. Again, just scratching the surface. But we're going to implement this get visitor method. So that by default, everything extends this tree visitor. Any language specific visitor, like the Java visitor we're looking at, it's built off of this tree visitor. And the tree visitor is parameterized by the tree type, which can be anything, and the execution context, which I didn't talk about much, but that's just one of the ways that we can populate data about trees and pass it between visitors. So just another way that OpenRewrite makes it fairly easy to communicate data, save data, and like make changes how you want to make. So in the big picture here again, this is the visitor, right? We have our Java visitor, and it extends that tree visitor. So there's our language specific visitor. So we're going to work with that. By default, just a super get visitor call, right? So it's just going to keep traversing the tree. Nothing happens here. Makes a change here. Then instead of just continuing to traverse the tree, we're going to actually see that change be reflected in our source code. So instead of just doing a get visitor call, we're going to return a tree visitor of the type that we want to use. In this case, we're working with Java, right? So I'm going to implement a Java ISO visitor, which ISO, it's not important. I wrote Java visitor. I wrote Java visitor in the big image because it's just easier to understand. ISO just means that it's going to return the same tree type that it works with. Again, not really important to how it works or anything. There is a Java visitor, but it's not as well used as this one. So we're going to return a visitor, and as we can see, here is where we make our changes. There are many different methods that you can implement. It first has this basic visit method that I was talking about. This is the generic one. It's going to by default call this method for each one of these, and then just continue to traverse the tree. But if we choose one of these, block, break, throw, any Java element, each one of these is a tree. So visit X is a type of tree. We can make changes to the code. So I'm going to work with the one that we were talking about earlier, which is the compilation unit. So we're going to work with the massive source file as a whole. So any Java file that comes in, we hit compilation unit, we visit it. So we're going to implement this. And again, just like the one before, normally it just continues traversing the tree. It doesn't do anything. But if we return something else instead, then we can see those changes. So just to keep with how it was on the slides, these are all J dot. So J is the Java tree, and each Java unit extends that tree. So a compilation unit is a part of the Java. It's a Java tree. Instead of doing this recursion, right, we can do this recurse. We get nested bits of the tree, but we don't want to do that. So instead, we want to return the tree, but different, right? So this is the tree. We're working with a j.compilation unit, which is a tree, and we want to do something to it. So what can we do to it? We can go into each one of these and see what we can do. What I want to do, as I have alluded to by the title of this, is I'm just going to do something silly, and I'm going to capitalize all the names of the classes in the file. Any Java file that has a class name, it's just going to be all caps. Make any sense why you want to do it, but it's just something that you can do. So I'm going to show it. So for each compilation unit that we have, we want to make an edit to it. And there's a ton of different stuff that I could not possibly get into today that a compilation unit has, since it's everything in the Java file. But for brevity, I'm going to pick the one that I want. I want to look at class declarations. And class declarations, if you remember, back here, class declarations are the whole thing, right? Any class declaration that exists, we want to look at that. And we're going to take this A, which if you follow the lines, we have a j.identifier, name, all the way over here. This is what we want to get. So we want to follow this track. We have the compilation unit, we visited one. We want to go down to class declaration, pick off the name, pick off the simple name, and then do something to that. I'm going to capitalize it. So that's just to keep everyone in the know about what we're doing. So like I said, we're in compilation unit, class declaration. We can go into that too, and we will find name, identifier, as it was in the diagram. Go to identifier, and we have simple name. So this is just the class name. So we're just going to traverse down into it and then pick off each one until we get it. So we're going to use these with implemented methods to do this. So we know we're going to get classes, right? So compilation unit has classes. So with classes, and then we're going to get those classes. Again, right here, if we return to right here, still nothing has happened. We have the same result. But we're going to keep going. So what's after classes? We're going to grab the names, right? So we're going to grab these identifiers. And we're going to get each and every one of them. And then for each one, we're going to get the name. So again, if I collect these, which what I need to do anyways, this is still exactly the same thing that we had before. We're just slowly getting closer to getting to the name, right? So same thing, just traversing through that. Now we have get name. So then we're going to get the simple name, right? That's one. C dot get simple name. Now we have the simple name. We're right there. Now we're just going to do uppercase. So have everything, and this is, you wouldn't probably do this in practice. You'd probably try and visit the identifier itself, but you have the compilation unit, and you're just going to go through, grab all the stuff, go to exactly what you want to edit, and then edit it, and then return. So for every single class name there is, we're going to pick something off, grab the name, and then capitalize it. So
are the width items optional, or is it required that you do with classes and then do stuff and then do with simple name, or is it a optimization?
It's just that the width is kind of like a way to, it's like the getter and setter kind of thing, but it's just like a even more of a shortcut. So it's just keeping it and then setting it. It's like pulling it down and then setting it. It's almost just basically just gets set. But that's just the way that OpenRewrite implements the width annotation, I believe. So it's not really optional. If there was a set classes, then you would just use that. Or et cetera, like that, for whatever reason. Yeah. Also, if anyone else has any questions as I go, I might be going too fast. So, please feel free to stop me. But yeah, I'll just package this up like I did with the other one. Let me get the terminal up and going here. Do and Maven install. And then you would normally test this, and there's plenty of documentation showing how to write tests and run tests. You can do that either Java or Kotlin, both are heavily supported. But we're going to go ahead and skip these tests because there might be one that I left in there not really working. Okay, so this is also going to be stored just like we had before. So if we go back here, we're going to select this one instead. So unlike the declarative YAML defined recipe, the vet to veterinary one, this one, OpenRewrite knows that it's in there. And I don't have to like put it in some YAML file and declare it somewhere. It knows it exists just for the sake of its package path, and it knows that it extends the recipe class. So it is recipes.class capitalizer. I believe it's recipes.recipes. It is. So it's just going to follow the package path, which is right here, recipes.recipes class capitalizer, and it will find it and it will know it exists. So we're going to run the discover again just to see, make sure it does know it exists. And for good measure. All right, so active recipes, class capitalizer. So it found it. It knew that it was a recipe that could be used. So let's go ahead and try and run. So yeah, I mean, again, like silly example, you would never want to make all your classes capitalized, but just kind of a simple, easy way to show like how something might be programmed by you or someone else, how it's packaged up and used. And parsing the source files. And done. See that changes were made to just about every class. And for once, we actually want to see all red because nobody likes an all capitalized class name. So again, super silly example, but just to show like how you can basically do anything you want with it. You can go visit certain parts of that tree, whatever you want to do, change certain things. The world's your oyster here. So yeah, I mean, that's all I really had for a demo. I think it's pretty cool how it works. I can go over some more stuff in detail afterwards if anyone's interested. But yeah, the demo recap. But the basics that I wanted to go over was, you have these built-in recipes that OpenRewrite writes, and they're super easy to run right out of the box. You just activate them in your build plugin, and they're good to go. They do exactly what you need them to do. But you can also write your own recipes, and they can be as simple or as complicated as you want. And they work just the same. And that's basically the idea I wanted to get across here. Some of the very popular, I listed some of the popular migrations that are listed on OpenRewrite site, stuff that is commonly used. These ones are much more complicated than anything I showed, and they have a lot of steps, but great use cases for like personal projects or anything you really work on that migrations that need to be done. OpenRewrite does them instantly, which is awesome. Author your own recipes. And yeah, okay. So that was a long-winded, what is OpenRewrite? How do you use it? Hopefully that was semi-informative. But now, real quick, I wanted to talk a little bit about using OpenRewrite at scale. Hopefully, like, your mind was turning a little bit, gears were turning about like what this could be used for, other ways it could be used. Like, really, the possibilities are endless. And I think that looking into like a framework migration is a good example to kind of show that. So open source software like OpenRewrite is used by us. We are able to leverage it to do a few things. First, enables users to automate upgrades, which is what we kind of saw. But these users are not like necessarily like users like you might think of. Thousands of application developers are able to automate upgrades for, say, a proprietary framework across the firm all at once and unify it in the way that we specify, right? So the idea here is instead of those people doing their own upgrades, which we've seen is an error, causes a lot of problems, takes a lot of time, right? We are able to, provide them an easy way to do it in an instant, right? And that's super valuable because it provides easy adoption. And that's a really relatable thing, I feel like. If a new version of something comes out and it takes more than just a click of a button to upgrade, it's like, I don't really need that right now, right? But when you're at a larger company and there's rules and regulations involved, there could be major vulnerabilities or security concerns. And you want to upgrade to those future versions instantly. You want the people that have your stuff do that as well. So having an easy way to adopt those things is the value is immense. As I said, unifying the way that it's done. When you have that many people doing the exact same thing, there's bound to be at least a few, if not many, that do it wrong, right? So that's what humans do, right? A fat finger here, a fat finger there, and then, so you want everyone to do it in the right way, do it in a timely manner and efficiently. So OpenRewrite is a great solution to that as well. I kind of said this out loud a little bit already, but imagine each team upgrading their framework versions across the entire company, right? A ton of work, and not just a ton of work, but a ton of headaches probably. And instead, the team that manages that proprietary framework can package up the recipes in the way that it needs to be packaged, hand it off to the customer, they upgrade it, and then it works flawlessly, right? So again, a lot of like lower level details, not really like focus here. But you know, the idea of using it at scale, I'm sure like you can imagine the possibilities here. So very valuable tool. But yeah, just kind of keep going here, kind of closing it off a little bit. There are a few things I noted here in the way of challenges and considerations. There's a small learning curve. I would say it's fairly small for the average developer to get into authoring recipes for OpenRewrite. For users of OpenRewrite, out of the box, it works perfectly, right? If you have a personal project that you're working on, or even, you know, maybe it's some sort of enterprise solution that just needs the recipes that are built in, perfect. Out of the box, it works great. If you have an advanced refactoring operations that need done, you know, then authoring those recipes could prove to be a bit more challenging, require some more time, some more effort. Reward is usually, it usually outweighs the amount of time that you might spend learning it. And then once you do know it, you have all the tools in your hands to keep going. So I also put project compatibility. Like I mentioned, it's fairly compatible with most languages and frameworks, but there's probably a few that you might, if you're working with something a little more niche, you might need to look into that and take that into account. And then some recipes can be time expensive. So, you know, you think about like a really, really massive repository, you saw that tree, even though OpenRewrite does a pretty good job of optimizing stuff, you know, you're running hundreds of recipes or something, there's a chance that it has a time total associated with that. But if it's just you just leave it running overnight, and that's fine. But if you're working for thousands of people, then maybe that is not a really great solution for you. Yep, just a basic conclusion here. You know, kind of talked about OpenRewrite, what it's capable of, the use cases. If you want to check it out for yourself, docs.openrewrite.org. Ton of cool stuff on there to get your own projects integrated with it. If you have been putting off I guess this is my call to action. You know, so if you've been putting off an upgrade or something, you know, give it a try. It could be a fun learning experience. I think it's a really cool tool. So yeah, that's basically all I got for you guys. If you have any questions, feel free to shout them out or talk to me afterwards. And yeah.
So I saw the creator of OpenRewrite speak about a year ago.
Yeah.
And he was at Netflix at the time, and he was very frustrated as a member of the platform team, how his libraries were not being upgraded and supported. And for about 3 years, he just kept going. Why aren't you upgrading? Why aren't you upgrading? And finally, they said, if you would just do it for us, we would do it every time. And that's when he got the idea of that. If you are a platform team and you're having people not adopt your stuff, this might be a solution for that.
Talk about how it might be used in automation, like dependency upgrades or, you know, part of the pipeline of checking code. Is it used at all like that, or is it kind of manual each time?
Well, so if you have that wrapper that I talked about, if you have something that is like this custom runner for the recipes, it might be more usable in that form. You saw how I used it. It might not be good for like constant code checking and cleaning. It does do that, but there's probably a lot of manual process that goes along with it. If you have that runner, kind of this wrapper around it that is able to parse those recipes, take them in, and then use them for your own purposes, then it could be better used for that. I think it definitely has the capability to do that, but out of the box, probably not.
Enforcing styling, enforcing linked
Yes.
suggestions and things like that.
It would be more of a one check, and then, you know, unless you had that extra thing around it to.
I'll disagree with that a little bit. I mean, I've done it not with OpenRewrite, but as a part of my Maven build, before running tests, always had a format of the code, and you want it before your test because in theory it's rewriting your code. It could break your code. So I could see things like the imports and some of them, maybe not the whole breadth, but maybe some formatting things have it, because anytime somebody checks in, you potentially break whatever standards you have. So
that is true. If you're working on like a single project, very often you have it brought in as a Maven dependency and stuff like that. That could be a good option. So
think also, right, it's not a panacea, right? So let's say major upgrades, we don't want to be automated. You need to be really, we want people to know what's changed, right? Because you'd be surprised when people say, this is magic, commit, and, then things don't break, right? So we try to resist basically putting those as part of the pipeline.
But things that are part of your sonar queue, that people are always breaking these rules, those would be ones that you might want to put in there.
So upgrades, but I think you're right, formatting, so that's what you could.
Yeah, and definitely like having recipes in that prepackaged format to have something that says like best practices, and then you have that running. That's the one you have on the side. That's a great use case.
Is it possible to interrupt out from the recipes as they run? Is there any output that it spits out that you can, things, reporting, detection of things that you want to monitor, but not necessarily change right away?
There is some out of the box. It's I'm not going to say fairly new, but it's being developed as we speak. So there, out of the box, there is some recording of stats that happens in the background. It's not available out of the box. It's kind of like deep in the system itself, and there's no way to activate it through like Maven goals or anything. But using something like that outer runner wrapper, you're able to access those data tables, use that information. You have some extra logging information in there as well. How long recipes took to run, which recipes ran for this amount of time, how many times they ran, all that kind of stuff. It's there, and I know that there's an effort to get that more available out of the box to people, but it does record that. Yeah.
Steve, do you want to answer your question?
Yes. So, do you know of any projects or any work that's happening on using like an LLM or, generative AI where it takes 2 releases of software, compares them, and helps you write the recipes?
I do not know of one, but that's a really good idea. I think you should run with that, right? That seems like a really good use case, though. I mean, I don't know of anything off the top of my head that is working on that, but definitely.
I'm going to chat GPT and say, write me an OpenRewrite plugin to solve all my code problems. Done.
Yeah, compare these 2 releases, find the differences, and create me a recipe.
Yeah, that would be really cool.
I think Amazon Q actually uses OpenRewrite. I think they advertised about this probably like a month ago. So they use LLM to analyze the code, and then they basically spit out all the recipes so then they leverage OpenRewrite to actually do the actual work.
So the demos you had showed it modified in place, and it's just working in your working space there. Have you seen anything with branching strategies where you'll run OpenRewrite into a branch and then somebody will look at it and then decide whether to adopt it as is?
Not automatically. It would then be that manual process where you would run it and then,
Just like you just make a new branch, run the recipe, make the PR, and see if you actually like the changes that are important.
Yeah, kind of an iterative process.
Or you're talking like GitHub where they automatically find.
Well, like dependent bot or something.
Yeah.
that would be, if that was automated, that'd be.
So underlying it uses the tree-based model.
Mhm.
So for example, is it possible for OpenRewrite to do this like in Java if you have multi-line comments and if you want to strip them out? So can it work multi-line?
Yeah, so it would depend on how it parses that. So that's a big factor, and it's something that I can also touch on as well. Certain languages are parsed in a certain way, and that's not accessible to you to decide how things are parsed. So, if it doesn't parse those multi-line comments in a way that is usable to you, I'm sure it does. I'm sure there's like a comment tree type, and it will. And I'm saying this as like the real answer is I'm not sure, And I think that there would be a comment tree type, and then you would be able to look into that and parse it that way. You're bound to how the underlying technology of OpenRewrite does that parsing. And they've changed that over time too. Like I've worked on recipes using, using a certain language, and then they change the way that it's parsed, and then something breaks, and that's why you have your tests. And then it's like, oh, it didn't think that was that anymore. There's like it's like an underlying type called a quark in OpenRewrite, and that means it doesn't know what this is, and it's just here, deal with it. And before it did know what it was, and then they had an update, and now they didn't know what it was.
When things like that happen, can you have recipes fix the recipes?
They wrote recipes, right? For recipes.
Yeah.
One of the upgrades, right?
Yeah. Recipes that recipes.
Annotation metadata available during traversal as you're going through the syntax tree?
Some. Like I said, a lot of that is abstracted away from you when you're developing. There is a good amount of information that it has associated with the data, but again, you're bound to what the parser lets you have. I think that, like, I couldn't say it all right now, but I think that if you could figure out by looking through, like, setting a breakpoint or something and kind of checking out all that you have access to. Towards the end of like the run cycle, so I didn't talk much about like the behind the scenes. It's a little more out of the scope of this talk, but like how recipes are executed in the background at the very end of that all, it flushes all that information out, and then you have an opportunity to grab that information if you have that. Like I said, not out of the box, but if you have something that can grab that information out.
On the vendor, are there non-open source versions where there's extra features?
Yes. So OpenRewrite itself, completely open source, completely free. There are integrations with some of their other paid products, but it's not really OpenRewrite. OpenRewrite is almost by itself. It's the kind of the black sheep of their products almost. They have stuff that kind of do similar stuff, but not like exactly this. So I'm not sure off the top of my head if they have direct integration with any of their products, but most of their stuff is like for large code quality stuff.
Can you talk a little bit about writing tests for OpenRewrite? Like, is it just almost like unit testing, but a few use cases per recipe, or?
Yeah.
I don't even know.
Yeah, I didn't touch on that much, just for the sake of time and everyone. But essentially, the way the tests are written is kind of like an assert statement, right? So you input an example of code that was before. You give it an example of what it should be after. It asserts those two after running the recipe. Now, obviously, it's more complicated than that, but you would pick use cases. So if you have something, let's say you have a recipe that makes a change to your POM file, changes a Maven dependency, but then it also goes searches through your Java files and checks to see if those dependency package names in the import statement also changed. You'd have your one test that checks to see the Maven stuff, and then you'd have maybe another test that checks to see the Java stuff. I have only tested using Kotlin. There is a Java way to do it, but they say that you should use Kotlin, and the Kotlin support is pretty good. Super like simple code.
How do you manage the order of precedence and how the recipes are applied and what goes downstream from the upstream?
So it depends on how you're running them. If you're doing it in the YAML file form, the declarative form that I showed, it's ran in the order that you specify it. And then as recipes are run, if you have them imperatively specified, they'll run right when they're called in the Java code. In addition to that, there's cycles. And typically, like most use cases, recipes will only run one cycle. But sometimes you can cause another cycle, and then you can bring data from the previous cycle into the second cycle, and then it'll run certain recipes that cause another cycle. So you kind of have control over that, and you say, like, maybe I want to go through once and then do this, but then after that's done, I'm going to run another cycle of it. And then you know what to change the second time. It's a little more niche use case, but you can control pretty well the order the recipes are running.
Steve, go ahead.
Do they use any frameworks along with the testing? Or is it pretty much just kind of internal or just normal JUnit types of things?
For testing the recipes that you write, you're asking?
Yeah, testing frameworks for the recipes.
Yeah, it's mostly, like I said, I haven't used much of the Java-based testing because the support for it is much less than the Kotlin side of things. The Kotlin is mostly just an OpenRewrite style thing. It's kind of theirs, and you, like I said, very simple. Just what was before, what is after. This is the recipe to run.
Yeah, I might recommend investigating ArchUnit. It might have some test capabilities to be able to do more complex things, like if you restructure your code to do package checking and those kinds of relationships. You can declare rules. Might have that capability.
Yeah.
Is this only for source code? It's not for bytecode?
Just for source code. It's very high level in the sense that you write your code, and then if you went into a debugger and looked at it, there's even tools that you can use to print the tree structure as you go and see what you're working with. It very much works with the actual source code. So
what is the minimum version of Java that it goes down to? 6?
I believe it might be 8, but there's a chance it goes below that. I know that from my development experience, I've primarily used it in 8. 8 actually might be the maximum version.
Run it or can modify the code up?
Code doesn't matter. It can be any Java. The actual runtime of the OpenRewrite, if you're developing recipes, for example, but you can use any Java runtime for that. I mean, I'm sure it goes down to, like you said, probably 6 or something.
I would imagine they have Java 17 plus.
Support for modifying the files, yes. But for the actual runtime of the OpenRewrite core,
Oh, okay.
don't know why. It's on Java 8 though.
Sure.
And we know that. We've run into some problems with it, thinking it's not on Java 8.
One of the problems I ran into.
Just thinking it wasn't. Plus 8 standards. But I don't know what the limitation there is, and if they start playing.
For larger recipes like Spring Framework upgrades, are you seeing much work after OpenRewrite runs? Manual adjustments to code? How much exactly are you seeing?
So our experience mostly with OpenRewrite is using it for our proprietary frameworks. So we're responsible for making sure that we cover all of our bases for our stuff. As far as the base Spring stuff that is covered, there's the occasional time where we'll find that something wasn't completely covered by the Spring people. There might be some upstream contribution effort for that, or letting them know, But for the most part, from what we've seen, work with the Spring side of things mostly, and the Spring team has done a fairly good job with that. But again, it's up to them to cover that.
Okay.
So,
Is it using Copilot, kind of like we said earlier, you make a feature bench, run rewrite there, make the PR, and you kind of just visually go through and make sure it didn't do anything weird. You don't just plan as Copilot to write a giant function. It's got to accomplish.
Just follow-up question, is this, for example, take the example of Spring, is it sensitive to how Spring is used by the particular projects?
yeah,
At least how effective the refactoring is?
Yeah, I'll repeat myself again because I can't give you a straight answer because I'll be honest, I'm not sure. But for the most part, it seems using it on a variety of different use cases of Spring. It seems to be fairly holistic in its coverage. And there will be one or two things every once in a while, depending on like maybe a minor version or whatever that. Yeah.
Is this the official source code refactoring software for JPMorgan Chase?
It is not.
Thank you.
Thank you for mentioning it. Great question. It is not. JPMorgan Chase does not endorse this technology. It is important. It was a good opportunity to talk and say, you know, that technology is used by larger companies, and that's a really good thing for a lot of people. We have people in their own time that work, you know, contribute to this technology, which is awesome. And contributors, which is a good point. Not paid to contribute.
Cross-language support. Different languages have different idioms. Java is where this started. It has its own set of idioms. Do you see object models for idioms that apply to other languages, like little wrinkles here and there that, like say a Go or a C# or something might have something in its own plugin or something? Or is it all just one modeling of it?
You can bring in what you need. So they tell you like, oh, if you're going to be working with Java primarily, this is the dependency you need to bring into that second project that I had where we're actually developing the recipes. It's like this is the stuff you'll need to do that. So there is some separation there, and they don't have everything all in one. But you could bring it all in, and it doesn't really matter. And you know, all pretty much the same, just language.
They have their own visitors, so you can do the other languages in their idioms.
Okay.
Yeah, so that was the one thing. So like you had the Java visitor, you could pick the language that you're working with. And that's like just by the nature of OpenRewrite, that's what they give you out of the box, which is really convenient. You don't have to use that base tree visitor. You know, it provides you with the capability to, this is the support that they have for you as a developer to work with Java and program recipes in Java code, or Java code. So.
Thank you, Ethan.